Elton Manufacturing, the Sagania Group, UL Solutions is sponsoring our Learning Lounge. And of course, we're very grateful to our sponsors. They provide us significant support. We really appreciate it. So we are going to, there it is. Our next session is on-site fenestration testing and analysis. Today with us, we have Maurice Quinn from Capacity Engineering out of Ottawa. Maurice is a structural engineer with Capacity. Capacity is an engineering firm working primarily in consulting, engineering, and project management. Their work includes the analysis and design of diverse structures, preparation of maintenance programs, detailed structural condition assessments, as well as forensic investigations and fire engineering. Their work encompasses services for industrial, commercial, institutional clientele as a full spectrum of services for the residential market. Maurice, welcome.
Thanks, Terry. So basically, what we're going to be talking about, do we start it or what's the easiest thing?
Sorry, let me get back in there. Good.
Okay, so the first slide is not much different, so I'll just leave it there.
Okay.
So as Terry said, we're going to be talking about field testing and fenestrations, and effectively what we're going to do is talk about what the test is, what the test isn't to some extent, the standards that apply in Canada. I'm going to try really hard not to read off the slide as well, so I'll let you see the rest of that for yourselves. The biggest thing is, of course, the problem right now, and the reason why I'm betting a lot of people listening to this don't like consulting engineers, is that there isn't much of a standard as to what the engineer is held to when they're doing their work. So there are standards, of course, that apply to the work. The E1105 is how the test is actually done. The pressures to which the test is done is specified by code under A440. The Canadian supplementary gives you a lot of information and gets specific about what pressure at what height in a given geographical location has to be applied. But at the end of the day, if the architect or engineer decides that they want to test the window up to the full maximum spec of the window that the manufacturer said, it just becomes a big fight. That's not reasonable. The code is a minimum standard for a reason. The supplemental standard, either supplement to the Canadian standard, is there for a reason. If you're using the correct pressure on site, that's really what you should be held to. And I find it very frustrating to be up against engineers and architects trying to demand that the window meet its basically lab pressure. I don't think that that's all reasonable. At the end of the day, what we're looking for is a national standard of some sort, some standard to which the consultants will be held. And that really comes down to training, calibrated professional equipment, a good checklist-driven system. So something along the lines of what aviation did to bring a lot of safety into their systems. I mean, I'm not comparing us to aviation. I'm just saying checklists work. So, hello? Where am I pointing, Terry? I'm not getting that.
Point at me and it should go.
Well, I think.
No.
Okay, so that's nature, right? That's actually a flood. It's a flood at the top of the South Island of New Zealand. I was down there visiting family, and this was between me and where I was going. This is actually a really cute babbling brook, if you can believe it. There's lots of beautiful photos of this location. Instead of a cute little babbling brook at the time, it was the busted banks, flood everywhere. At the end of the day, this is what we're defending against, right? Building envelopes keep Mother Nature out, and it's a matter of making sure that things are correct. The test is to simulate a reasonable standard. The amount of water we throw at a building during the test exceeds any amount of water that falls on the face of the planet. It's nuts. No, this isn't working, Terry. I don't know if it's off or did I turn it off or I don't think so. It's on.
Okay, that should be okay.
All right.
It's because I was clicking in there. That's why.
Technical issues. Fingers crossed. Okay, so why do we test? We test to show compliance with the code and the contract. We don't test to force things to fail. We don't test to try and make somebody have a problem or a bad day. If a consultant shows up and they do their job properly, either your window and the assembly, one and or the other working together, failed or passed. And it should be done to a very simple, competent standard. It should be predictable, and you should know in advance, most likely, whether you're going to fail or not. The standards we already talked about briefly. I'm just going to skip that. What equipment? So our position is that all of the equipment should be purpose-made equipment created for that job, calibrated to the job the day before and the day of, with the calibration provided to everybody involved after a reasonable notice period prior to the test. There should be transparency. There should be simplicity. There should be a nice, simple way that you can look at the report and read it and see what the results are. Right. So the other thing that we find very frustrating is oftentimes what we refer to in the office as fail and walk away gets done. Did it leak? Yes. Okay, my job's done. Bye-bye. I'm out of here. No, thank you. That's not how it works. Find the leak, locate the cause, use some simple tips, tricks, anything you want to do. Again, there's very little standardization, so a team can learn how to do it for themselves, learn different things that work for them, create their own water stops, supplement the caulking, find the holes, actually make sure that it's draining properly, make sure it was clean in the first place. How about using UV reactive dyes to see whether or not, as soon as you have a leak, stop all your water testing, concentrate specific locations, mask out, determine whether or not you can locate the exact source of the leak. The cause can be found. It's not that hard. Checklist driven. Prior to the test, during the test, and post-test. Checklist, checklist, checklist. We've got a bit of a method we use in-house to try and figure out whether or not we can predict how things are meant to be working, whether or not we think the detail really suits the conditions, and whether or not we think it's a good detail in the first place. We refer to them as the Ds of detailing. I'm sure if you've ever done any kind of architectural technology, any industry work with building envelopes, you've seen some variation on the Ds. People talk about these all the time. To us, they're pretty important. We look at the details that we're going to be testing. We try to figure out exactly what type of building envelope we're dealing with. It's no sense testing something that's meant to be draining when there's water stops all over the place, or people have put temporary gaskets in, or even just regular detritus on the construction site has filled up the weeps. It's not going to work. It's going to fail. So we talk about deflection. So getting the water out, the primary building envelope actually knocking water out of the way. Draining and drying. Oftentimes we come to site and we see, even in fairly new construction, of course, we should only be testing new windows and doors. What's new? Ultimately, we find a lot of the time these are filled up. Sometimes it's bugs. Every once in a while you get a spider nest. You get all sorts of different things that are blocking it. And of course, that can lead to problems because it's just not draining. Direct and divert, pretty straightforward. This flashing leaned towards the building. That's not what flashings are meant to do. Inclinometer is a very quick trick. It's unfortunate it's a bit dark for the picture, but this is showing a right-hand slope of 2.8 degrees. It's not going to work. That's not how it works. Defend it. So this one's a bit full on. I thought this was a funny detail and a great photo of a funny detail, so I've included it. But yeah, that's a lot of blue skin, but the idea is there, right? Ultimately, if you've got a membrane of tape, caulking, coating, you're going to be defending once the water is in position. Dams, water stops, limits the travel. Step down. This one drives me crazy. The number of times we see on construction sites that because of some constructability issues, some staging issues, some timeline as to whether different trades came in at different times for different reasons, or a repair, you have the membrane
They restarted the session.
Oh, well, there you go. Two halves are better than none.
I'm going to restart here.
There you go.
Hang on.
I bet you're right. Because I was trying to make it work. All right, that's way too far. Hold on. No, hold on. Back. Yeah, avert your eyes.
Yeah.
All right, here we go. Let's try that again. Right. So fundamentally, we don't always test when we're asked to test. That's going to sound a little strange, I'm betting, but I don't want to test something that we can't reasonably and easily clean. If it's not clean, it's not being given a fair shake at actually passing. If we are going to test an assembly, it's because we think it's going to pass. If we think we can easily tell by some form of field review that something doesn't look good, we're not going to test it. We're going to tell somebody, hey, something's wrong, something doesn't smell right. We're willing to test. You pull the trigger, go ahead. But here's the reasons that you failed our preliminary checklist. We don't think it's a good idea to test today for the following reasons. Though we do test in the rain. By the way, these two young guys run two of the teams doing testing, and yeah, they wind up in the rain. I bought the nice jackets. It's not my fault. All right. So ultimately, when gusts do cause a problem, it's rare that we will refuse to test. But if you're already in stormy conditions, running the test might be a bad idea. I don't care what your timeline's like. But most of the time, weather's not an issue for testing. Anyway. Okay. Diagnosis. This is what we were talking about. We don't like walking away, finding that there's water, or God help us, that there's actually some other cause of some apparent ingress and there's no ingress. That's really going to go well. Ultimately, we're trying to figure out what will cause, or what will be the problem that needs to be resolved to then make it test. We're not trying to get you to get us out there a half a dozen times. We want to sell our services on the quality of the service, with a report that you can read, with an answer that makes sense to everybody, with a defensible position and pressures that are sensible and reasonable, etc. In my opinion, we still have kind of the Wild West going on. There's not a standard that the actual testing guys are held to. Earlier on, I had some cheeky Latin up there. For a guy who almost became a priest, that's kind of an easy trick. But ultimately, quis custiat ipsos custido is who watches the watchers in English, right? Who is keeping an eye on the consultants? And the answer is nobody. You get into a fight with a consultant, the consultant's just saying he wants or she wants what they want because they want it. And then if you've got a situation where that jumps in after the contract was formed, you should really talk to somebody who knows enough construction law to talk to you about contract A, contract B, about them bait and switching you, about them causing you problems under contract after the fact. That has all sorts of juicy consequences for you and the right consultant to help you make that argument. You shouldn't be held against an unreasonable standard. Yes, the code is a minimum. Sure, the architect or consultant will get a better product for their client, but at what cost? Economy comes into the code. The code is a reasonable standard. I'm primarily a structural engineer. As a structural engineer, my code is designed such that 1 in 50,000 people in this country will die in a structural collapse, statistically. That's the basis of the code. 1 in 50,000 fatality in structural collapse. That's the level at which the country has decided it's reasonable that that will fail, that the systems will not work out, that all our probabilities and our bell curves fail. It's not that different in windows and doors. The standard you're being held to is unreasonable 99% of the time, or a misinterpretation, or an exaggeration, or a misinterpretation of your contract. You're not being treated fairly. Demand that you are. Right. So who's at fault? Basically doesn't matter to me. A lawyer's going to find out about that in the end, or somebody's going to fight about it. I'm going to tell you whether or not I can have a problem when I test in a reasonable manner, according to reasonable standards, in accordance with the code's reasonable pressures. That's what happens for me. After that, whose fault it is doesn't matter to me, else you pay me different money with other people supporting me. I've got a very good construction lawyer. We don't fail and walk away. That's the bottom there. So engineering investigation, I keep this one in here just because, or we threw this in here just because I don't really care about your linings. I know that the house is very pretty and the contractor doesn't want to have to tear holes in it. Too bad. If you limit what I can see, I can't do my job. We are sometimes going to have to ask to have a hole, to have things torn up. It's just the way it is. Looks very not nice. It is not a pretty thing. It's an expensive thing. I can't change that. So this is just a one test that we had. And I like calling this photography by app. If you look at the leftmost photo, we don't have the nice little rainbow of the previous photo of our spray rack, but you can see that the application auto-corrected so that the rod, which is actually on an angle, is the dominant vertical piece. The support of the spray rack is meant to be on an angle and everything else is meant to be straight. But computer said no and decided that it would be the support rod that is the vertical element. I thought that was hilarious. Just the best photo. So again, UV reactive dyes are really useful in the right situation. Plumber's putty is your friend. You can mask things out. You can mask things in. You can play different tricks. We can do 3 different series of tests and see the distinct water coming in at a distinct time for the right reason. Right material at the right time with the right skill set, we find the problem. Not all of your UV reactive dyes are your friends. We put a lot of time into figuring this out. You put the wrong UV dye in and you are going to have a permanent stain on concrete, steel, aluminum, you name it. So, I would not lightly recommend this trick. This one has its risks. This was one of my favorite failures. It looks like we did a temporary dam with plumber's putty, but no. Unfortunately, every once in a while, I am actually the person that the installer and manufacturer should hate because I point out that you put something in and that apparently I'm told this one came from the factory like this, which I didn't believe at first. And I still withhold judgment, but there is a sort of a semi-elastic mastic fixing the gasket in the corner of this window, if you can believe that or not. And it was the source of the leak. The gaskets should never have been kept in place. They should have been replaced in their entirety. When we tested this window, it leaked very slowly. It had caused all sorts of problems. Other teams had already tried to figure it out and couldn't. When we did our method where we go slowly around with our dye penetrant, we found the problem and it was very, we should have found it before we tested the window. I was actually a little ashamed that we hadn't already pointed this and been like, really? Are you sure? So this is actually from a structural presentation, but I'm hoping that it's bright and clear enough for you guys to tell. Ultimately, we do a fair amount of forensics, doing window and door testing, fenestration work, WIT testing. This is an additional forensic thing that we do. That's how we got into it. This bolt, I'm going to give it away because it's actually based on a student presentation. I tease them, I show them the bolt and I turn it, but this is an automotive bolt that was used in a structural detail at a cantilevered column base. And when they finished the work and started trying to walk away, it popped and they stripped out these bolts. I've got 3 views of this bolt, but it's actually an SAE automotive bolt that was subject to ASTM structural loads. And it ripped itself apart and shot across the construction site. So the point about it is knowing when to worry and why. And the ultimate conclusion of it is, you know, this is one nut that should have never cracked. Yeah, good, eh? Yeah. And don't worry about the winter, the rain's coming. The guys liked it. I was like, that's the worst dad joke ever. Like, I can't put that in. They were very happy that it was in there. So blame them and my, I guess, immature mind while writing this presentation for you. In summary, why we test is to show compliance with code and contract. It's not to see when the window will fail. We're not in the lab. We're not doing your job. We're not your techs trying to figure out how good this window will be, what the maximum pressure is. We're just seeing code and contract. We try to plan, notify, test, and diagnose. We work really hard, and nobody should be testing and walking away. If you get a report from somebody that's almost illegible and doesn't talk about the cause of the problem, they're not your friend. Something's gone wrong somewhere. And frankly, you should be able to go back to them with something like a wonderful document that's certainly coming in time from Fenestration Canada, right, Terry? Yes. That would be able to say, hey, you didn't do it, right? There weren't checklists. It wasn't driven by purpose-made equipment. It wasn't done with calibrated gear. It's not done to a standard that shows what might be the problem or is the problem and what could be solutions. Don't accept that they just beat you up and walk away. It's not okay. Report in detail with clear evidence, ideally with a proposed solution. So that's it, guys. I've got two of the guys here if you want to talk to them about what they do in testing, but I don't know how I did for time. I'm hoping okay.
Yeah, you're.
There you go. Lots of spare time for you.
Yep.
Does anybody have questions? Anybody want to talk about how bad one of my reports were? Anybody had one of mine across their desk? Anyway, happy to take questions here for a bit.
I've got a situation that's purely hypothetical that I'd like to discuss. You know, where let's say a manufacturer provided windows for over 300 suites in 5 buildings, and they were all occupied except the very last building, and they put it up for sale to another company, and then after the fact, that other company comes in and decides they want to do the field water control testing, which is not a part of the contract. They took the slider windows were rated at 330 pascals. That's a stretch to get that. If you make it like that, that was a test that was based on a single slider. The configurations that they bought was 3 tall, 2100 millimeters high. And so the sliders would not pass at the laboratory rated value of 330 pascals. And they said, your windows do not meet code. Please replace all the windows in the building because they don't meet code.
Oh, okay, that's a great question. But look, there's two things, and I'm going to be quite straightforward. I would ask if the contract was novated. Like, did it go between the organization the contract carried over? But I'm not a lawyer, so I'm not supposed to. So we'll just put that aside. Maybe get the lawyers to look at what actual contract applies. But in the absence of contract, code applies. In the US, the accepted standard is generally the AMA or AMA. People say AMA, the AAMA 302, the 2/3 of the pressure, but they don't have our supplementary standard. So in Canada, you're telling me that because remember, the code is the functional statements. You're going to give them a reasonable water tightness. That's all the code says. After that, there are acceptable solutions that reference a whole bunch of standards. So unless somebody did some pie in the sky fancy thing, it's the acceptable standards that are going to be applied. Okay, acceptable solution, which includes standards, reference standards. The reference standard is A440. A440 in Canada has the supplementary standard. Ask the engineer or architect who's doing that, where did you get your pressure? Because if you read it off my window, I don't care if the Ferrari can go 320 kilometers an hour. You paid me for a car that goes on the road and it only does 100 kilometers an hour. That's the standard you're held to. And if you've got the right consultant, they should be able to fight that fight for you. And coupled with the right construction lawyer, I would say in a situation that you should be looking at a tort. And that falls outside of what I'm allowed to do. But it sounds like somebody is holding you to an unreasonable standard that the right team can walk a justice towards. Your Honor, the following is the situation. You get into something we talk about, the agreed statement of facts. So we create a statement of agreed facts. The lawyers with their forensic engineers, because forensics is of and relating to the law. It is slowly gaining an extra meaning. Scientific analysis of things. That is the fault of forensic TV drama. That's not what it is. Forensic engineering is of and relating to the law. It is an engineer helping a lawyer with facts, creating a factual story. And that story in your case should tell people we are held to the code. The code references this pressure. My windows pass this pressure. And by the way, and I'm going to cheat a little here because I was in a code committee or a code committee with Fenestration Canada, and I was reminded that all of these standards apply only to new windows, but define new installation. So then you're also going to have that argument. But that's an argument that you may or may not win. People will have different opinions, but there's no room for opinion in a technical standard. The technical standard is your pressure is what comes out of the supplement. That's it.
However, Dave, I know We do quite a bit of light commercial work. Manitoba has had a whole lot of this stuff because it originated there to a pretty fair extent. We have lots of pressure on now that if you design a window for that setting, right? That you pre-test it as configured, not as a simple single slider, and then all that water shedding down onto the slider. It better be able to make that work. So I think for our industry, there are two very distinct different components here that we have to be smartly aware of, right? That's totally right. There's way too much shit that happens. They show up, you're not there, you don't have a clue what they're doing, and you have all kinds of problems, et cetera, et cetera. But I do think we need to be far more cognizant as an industry of what you're up against, because more and more of the building envelope engineers are doing a pretty good job of speccing out the saying, wait a minute, this is the window, this is the height of the building, this is the configuration of the window. You need to test it to suit that. So it's a complicated topic, right? That your theoretical situation, you might lose that one. I don't know.
Well, I think the important point is this stuff needs to be done upfront at the planning and initial construction stages, not imposed after 4 of the 5 buildings are fully occupied.
In my opinion, and I mean, I respect people's opinions. That's great. And ultimately, the only way you'd know for sure is after a judge tells you what's the answer, and then nobody appeals or everybody appeals, and then ultimately the judges tell you what the answer is. We don't know. Sometimes it's very unpredictable. But in my opinion, the technical requirements of the code apply to a project that does not have any other specification. If there's no location in the contract documents that refers to a spec on the architectural documents or any other such thing, only the code can apply. And then if only the code can apply, in absence of any other agreement, you're going to have the code minimum. The code minimum dictates less than 330. That's it. Test the code minimum. If you violate that, you're harming the building. In fact, the consultant should be chased for erroneously harming the building through testing, in my opinion.
You're hired.
I have the world's smallest juice glass for water, and I gained 45 pounds during COVID. I think it's a bit of a conspiracy to make me look even bigger. It's not just me, right? It's a tiny, tiny water glass and a very large man. Anyway, other than the stand-up comedy, is there any other questions? I did notice the naughty word, and I'm trying really hard not to use them myself. I have a reputation around the office, so I'm doing well. Nobody's waved at me. They're both supposed to wave at me if I start using voices or cursing. The classic voice around the office is, your window failed. Don't you both wave now? That it? Was I that thorough, or am I that hated? It's got to be one or the other. I know how this works with manufacturers. All right, there you go. Thanks so much.
So thank you, Maurice. Appreciate it. So we brought Maurice in as sort of a follow-up to a task group that's been created within FenCan that is looking at this situation of and confusion, et cetera, et cetera. Being a professional, he's going to be bringing a lot to that group. We've had a number of meetings already. There's about 20 of us, Dave, 15 of us, something like that. And the desire is to, wade through all of this topic and develop some advisory / guidance documents for our industry, as well as for the testing industry, because listening to the feedback that we've been getting, it's not just our problem, and we're not making all the mistakes that are making this such a challenge. There's a lot of challenges and problems coming out of the industry that's doing this testing, and the contractors that are in the middle of it that don't understand and don't provide sufficient communication about when testing is and what's in the spec, and was it meant for that product. I mean, it goes on and on and on, more than we can certainly get into here, but we're working on it. Hopefully we're going to have something out early 2023, and there's going to be a couple of different documents that come out of this group. So it's a great topic. It's really it's high on our priority for our members because it's such a problem. And it's not being well addressed historically, and it's only getting worse. We're seeing more and more testing. Certainly Alberta is seeing more. In BC, it's been a huge problem for years. Ontario is starting to see more and more as the demand for better buildings increases. These tests are going to increase as well. So we're trying to get ahead of it now. We appreciate Maurice's input today. Thank you very much. In about 20 minutes, we're going to hear from Enercan. Last words.
Well, I was just going to say, I thought there was a 50-50 chance that I was meeting with Madame Guillotine today. So I did include extra slides for questions. We clean things, you check the calibration, right? Spray rack distance. I'll just get them all in there for you.
There you go.
And there's your own website. There you go. Very good source of finding your actual pressures.
Just one question.
Yep.
Ideally, you measure the pressure difference between the outside of the building and the test chamber. Whereas what most do is they measure the pressure difference between the test chamber and the room pressure.
So the ideal is outdoors. That is the correct source. If you're going to use the corridor, you either have to justify that and adjust for it, look at the different pressures, or you can actually, generally speaking, if you arrange in advance, you can get that pressure, or sorry, you can get the corridor open to outdoor pressure. That'd be the ideal solution. But yes, it is a problem, and it can be a problem, but it can also be addressed. And in most situations, you don't even need to worry about it because it's going to be a differential that goes in your favor for testing. Whereas what you're worried about when you're getting into a forensic case, a true forensic case, like what you're dealing with, guaranteeing that you gave the actual pressures from the supplement, well, then you're going to be doing those things. You're going to be playing those games. You're going to try and make sure that you dot those I's and cross those T's.
Thanks.